Section 6.4, Coordinate Proofs. Objectives. Students will successfully use distance formula and slope to determine the best name for a quadrilateral given the coordinates of its vertices. Before we start doing this, we need to remember some formulas. Our distance formula is the square root of parenthesis, parenthesis, minus square plus parenthesis, parenthesis, minus square, and then inside the square roots in the parentheses, x2 minus x1 plus, and then in this parenthesis is going to be y2 and y1. Okay. Slope, we have to remember, is y2 minus y1 over x2 minus x1. From previous units, we learned the parallel line slope theorem. Two lines are parallel if and only if their slopes are the same. Perpendicular line slope theorem. Two lines are perpendicular if and only if their slopes are negative reciprocals. And to refresh your memory about what a negative reciprocal is, if we had 2/3, the negative reciprocal of 2/3 is negative 3/2. So 2/3 and negative 3/2 are negative reciprocals. To refresh our memory on how to do this, I have a few examples for you. So, line AB has a slope of 3/4. Line CD goes through the points 12, 9, and 8, 6. Is line AB parallel or perpendicular to CD? In order to decide, we must find the slope of line CD. So, the slope of CD is equal to y2, 6, minus y1, 9, over x2, 8, minus x1, 12. 6 minus 9 is negative 3. 8 minus 12 is negative 4. A negative divided by a negative becomes a positive, so we can reduce that to positive 3/4. We now need to compare that to our slope of AB, which in the problem it said the slope of AB was 3/4. So the question you got to ask yourself is, are these the same or negative reciprocals? So hopefully you answered those are the same. According to our parallel lines theorem, if the slopes are the same, then the lines are parallel. So line AB is parallel to line CD. Another example with lines EF and GH. EF has a slope of 2/3. Line GH goes through the points 5, negative 10, and 3, negative 7. So is line EF parallel or perpendicular to line GH? So again, we're going to find our slope of the one with the points. So the slope of GH equals y2, so negative 7, minus negative 10 over 3, because we have to stick with the same point we started with, 3 minus 5. Minus and negative becomes plus. Negative 7 plus 10 is 3. 3 minus 5 is negative 2. Our slope of EF was positive 2/3. So comparing those are not the same number. Are they negative reciprocals? So if I change the sign and flip this first fraction over, do I get the second one? The answer is yes. So those are negative reciprocals. So according to our perpendicular lines theorem, line EF is perpendicular to line GH. Okay. We have gone through a lot of shapes and properties, and I've created a chart for you so that hopefully you will be able to keep track of what properties are for which shape. So we're going to fill in an X every time it is true for that shape. So for parallelograms, are opposite sides parallel? Yes, they are. Are opposite sides congruent? Yes. Are opposite angles congruent? Yes. Do diagonals bisect each other? Yes. Are 4 pairs of consecutive angles supplementary? Yes. Those are the 5 properties that we discussed when we talked about parallelograms. Are diagonals congruent? No. Are diagonals perpendicular? No. Do diagonals bisect opposite angles? No. 4 right angles? No. 4 congruent sides? No. Exactly 1 pair of opposite sides parallel? No. Exactly 1 pair of opposite sides congruent? No. 2 pairs of consecutive angles supplementary? No. 2 pairs of consecutive sides congruent? No. 1 set of opposite angles congruent? No. 1 set of opposite angles bisected? No. Do they have reflection symmetry? We're not going to worry about this category here. Okay, on the bottom 2, we're not going to worry about. Okay, for a rectangle, let's go back through. Is a rectangle a parallelogram? Yes, it is. So all 5 of the parallelogram properties are true for a rectangle. So we need to find some other properties. Okay, are the diagonals congruent? Yes. Are the diagonals perpendicular? No. Do the diagonals bisect opposite angles? No. Does a rectangle have 4 right angles? Yes. Does a rectangle have 4 congruent sides? No. Exactly 1 pair of opposite sides parallel? No. Exactly 1 pair of opposite sides congruent? No. 2 pairs of consecutive angles supplementary? No. 2 pairs of consecutive sides congruent? No. 1 set of opposite angles congruent? No. 1 set of opposite angles bisected? No. Okay, move on to rhombus. Is a rhombus a parallelogram? Yes. So that means all 5 of the parallelogram X's are also true for a rhombus. Moving further on, let's see if any others are. Are the diagonals of a rhombus congruent? No. Are the diagonals of a rhombus perpendicular? Yes. Do the diagonals bisect opposite angles? Yes. Is there 4 right angles? No. Is there 4 congruent sides? Yes. None of the rest of those properties work. Now, according to our definition of a square, it is both a rhombus and a rectangle. So if rectangle has an X or rhombus has an X, square gets an X. So the first 5 all get X's. The next one, rectangle has an X for it, so square has an X. Same with the following, all the way down to 4 congruent sides. Our kite is not a parallelogram, so opposite sides are not parallel. Opposite sides are not congruent. Opposite angles are not congruent. Diagonals don't bisect each other. There are not 4 pairs of consecutive angles supplementary. Diagonals are not congruent. Diagonals are perpendicular. Diagonals bisect the opposite angles. No. 4 right angles. No. 4 congruent sides. No. Exactly 1 pair of opposite sides parallel. No. Exactly 1 pair of opposite sides congruent. No. 2 pairs of consecutive angles supplementary. No. 2 pairs of consecutive sides congruent. Yes. Okay. One set of opposite angles congruent. Yes. One set of opposite angles bisected. Yes. For trapezoid, is a trapezoid a parallelogram? No, it's not. So none of the parallelogram properties work. Are the diagonals congruent on a trapezoid? No. Are the diagonals perpendicular? No. Do the diagonals bisect opposite angles? No. Are there four right angles? No. Are four sides congruent? No. Exactly one pair of opposite sides parallel? Yes. Is exactly one pair of opposite sides congruent? No. Two pairs of consecutive angles supplementary? Yes. Two pairs of consecutive sides congruent? No. One set of opposite angles congruent? No. One set of opposite angles bisected? No. And our last category is our isosceles trapezoid. So since it is a trapezoid, the trapezoid properties have to be true for an isosceles trapezoid. Again, the 5 parallelogram properties are not true for it. So we have to move on after those 5. Are the diagonals congruent? Yes. Diagonals bisect opposite angles? No. I skipped one. Diagonals are perpendicular? No. So I just did diagonals bisect opposite angles? No. Four right angles? No. Four congruent sides? No. Exactly one pair of opposite sides parallel? Yes, because it is a trapezoid. Exactly one pair of opposite sides congruent? Yes, because that's why it's called an isosceles. Okay. Two pairs of consecutive angles supplementary? Yes. Two pairs of consecutive sides congruent? No. One set of opposite angles congruent? No. One set of opposite angles bisected? No. So, this is a summary of all of the properties that we have learned about all of our shapes. Okay. It would be good for you to practice this so that you can fill that out on your own. What we are doing in this section is using this information. So, let me readjust the screen here. A little bit further. Okay, we are determining whether quadrilateral ABCD is a parallelogram, rhombus, rectangle, square, trapezoid, isosceles trapezoid, or a kite, given the ordered pairs of the vertices. Okay. So our first thing that we want to do is to draw a quadrilateral so that we can have something to write on. So I'm just drawing a shape, a quadrilateral shape. It doesn't necessarily mean that this is what it's going to come out to be when we're done. A, B, C, D, and I'm going to write their ordered pairs next to their point names. So negative 6, 9, 5, 10, 6, negative 1, and negative 5, negative 2. We are going to use slope, which our slope formula is y2 minus y1 over x2 minus x1. And we are going to use distance formula, which is, again, the square root of x squared minus x1 squared plus y2 minus y1 quantity squared. All inside that square root. So first, to kind of make this a little simpler for us, we're going to find the distance between the x values and the y values of segment AB. Okay? So I'm going to call this AB sub x, which that represents our A sub x minus our B sub x. So our x values subtracted. A's x value is negative 6, minus B's x value of 5. Negative 6 minus 5 is negative 11. A, B sub y means we're going to find our differences of our y values. So it's going to be A sub y minus B sub y. Our y value of A is 9. Our y value of B is 10. So 9 minus 10 is negative 1. Now, if we look at our slopes, isn't it the y difference over the x difference? So our slope can be actually simplified. The slope of segment AB can be simplified by us taking our y value difference, so negative 1, over our x value difference, negative 11. Negative 1 divided by negative 11 is 1 over 11. Now, the next part on our problem that we're going to do, we want to label our picture, and we're going to label it as we go. So, I always write the slopes on the inside. So, the slope of AB is 1 over 11. Now we need to find the length of AB. So AB's length is the square root of, and it's x's subtracted and y's subtracted, which is what we just did up here. So we put our x's in the first parenthesis, negative 11 squared. Put our y's in the second parenthesis, negative 1 squared. Negative 11 squared, a negative times a negative is a positive. 11 times 11 is 121. Negative 1 squared is 1. So when I simplify that square root, I get the square root of 122. I am going to take that and write it on the outside of our quadrilateral. I'm now going to move on to segment BC. So we're going to do BC's x values, and we're going to do BC's y values. So B's x value is 5, minus C's x value is 6. 5 minus 6 is negative 1. BC's y values are 10 minus a negative 1. 10 minus a negative becomes into a plus, so 10 plus 1 is 11. And now our slope and our distance formulas are much simpler. So our slope for BC is the y's, 11, over the x's, negative 1. 11 divided by negative 1 is negative 11. Our distance of BC is the square root of our x's squared plus our y's squared. Our x's were negative 1, our y's were 11. So negative 1 times negative 1 is positive 1. 11 squared is 121. Now, 1 plus 121 is 122. So our distance of BC is the square root of 122. So we're going to go write these two values up on our quadrilateral. Negative 11 is going to go on the inside. The square root of 122 is going to go on the outside. So far, it's looking pretty good. We have 2 left to do. We are going to do CD next. So CD's x and CD's y. So our C's x minus our D's x, our C's y minus our D's y. So we just have to plug in 6 minus D's x, negative 5. 6 minus a negative 5 becomes a plus, so that becomes 11. C's y is negative 1 minus D's y, which is -2. Minus a negative turns to a plus. -1 plus 2 is 1. So our slope of CD is going to be the y's, so 1 over our x's, 11. So I'm going to go write that on the quadrilateral. 1/11 is our slope. Now for our distance. So the length of CD is equal to the square root of parenthesis, parenthesis, square plus parenthesis, parenthesis, square. Our x's go in the first, so 11. Our y's go in the second, 1. 11 squared, to simplify, we've got the square root. 11 squared is 121. 1 squared is 1. So we get the square root of 122 when we add those together. So write that on your picture. And now we need to do dA. So we're going to do dA's x, dA's y. So this is going to be the d's x value minus the a's x value. And this is going to be the d's y value minus the a's y value. So d's x value is -5 minus a's x value, -6. -5 minus the -6, that becomes a plus. So -5 plus 6 is 1. D's y value is -2 minus a's y value is 9. -2 minus 9 is -11. So now our slope for dA is going to be the y's over the x's. So -11 over 1, which simplifies to -11. Write that up on your quadrilateral. It's a slope, so I put it on the inside. dA, the length of dA, is now going to be the square root of, and we want to do our parentheses and our square. So our x's go first, 1, our y's go second, -11. So we have the square root of 1 squared is 1. -11 squared is 121. So we get the square root of 1 plus 121 is 122. So we're going to write that on our quadrilateral, the square root of 122. The math is done. Now it's time for the geometry. We now need to compare. So the first thing I'm going to compare is our slopes. If I look at 1/11 and -11, are those the same or are they negative reciprocals? Or are they neither? 1/11 and -11 are negative reciprocals. And if I check around, all the consecutive sides have negative reciprocals. And negative reciprocals for slopes means that I have perpendicular lines going around my quadrilateral. Okay? So again, when slopes of adjacent sides are negative reciprocals, of each other, so the sides are perpendicular. This is the thought process that was going through my head that allowed me to put the boxes on there. Do you have to write this out as part of your answer? No, but I want it clear what you're supposed to be doing. Okay. Now, looking back at our picture again, I now want to look at the lengths of our sides. Opposite sides are congruent, but all four sides are congruent, so that's even better. So let me mark all four sides are congruent. So now I have two things that are going to help me. I look at my picture and what type of shape has 4 right angles and 4 congruent sides. So I hope that after us going through our table, 4 congruent sides, 4 right angles, that's our square. So quadrilateral ABCD is a square. This is your final answer. You have to write a sentence to summarize what you have found out on your shape. You can't just leave it up to me to assume that you know what shape it is. I have some further practice that I want to work on. Let's move out of having to worry about doing distance formulas and stuff. So I want to look at these with you. Let's pretend that I went ahead and did these for you. So if these are our values, these here, length of AB is 2. I should write them on my picture. Length of BC is 2. Length of CD is 2. Length of DA is 2. So I've written those all on the outside because they're lengths. My slope of AB is 0. The slope of BC is undefined. My slope of CD is 0. My slope of DA is undefined. So, looking at this picture, I now know, and this is the point of this whole unit or section, I now know I have 4 congruent sides. So, looking at the inside, I have to decide what shape this is. These are slopes. Well, these two tell me that they are parallel because they're the same. Undefined is the same as undefined. So AD and BC are parallel. But now, are undefined and 0 negative reciprocals of each other? So if I take 0 and put it over 1, flip it, and change the sign, what does that reduce to? That reduces to undefined. So these two are negative reciprocals. So I have a perpendicular line. These two are negative reciprocals. These two are negative reciprocals. These two are negative reciprocals. So again, I have 4 congruent sides and 4 right angles. So quadrilateral ABCD is a square. All right, one more, just to make sure you got it down. Determine whether the quadrilateral ABCD is a parallelogram, rhombus, rectangle, square, trapezoid, isosceles trapezoid, or a kite. So then I have the points. I have done the slopes and the distances for you. We just now need to write them on our picture. TR is the square root of 32. RA is the square root of 50. AP is the square root of 200. PT is the square root of 50. Our slopes are TR is 1. RA is negative 7. AP is 1. And PT slope is negative 1/7. Going around the picture, I see I have 2 sides congruent. And I have 2 sides that are not congruent. Looking at our slopes, I have 2 slopes that are the same, so that means those 2 sides are parallel. These 2 slopes are not the same. So, looking at that, a quadrilateral with 1 set of parallel sides is a trapezoid. A trapezoid with the legs being congruent is called an isosceles trapezoid. So, quadrilateral ABCD is an isosceles trapezoid. Okay. All right. So that is what you're going to be doing on your homework. Your homework is coordinate proofs worksheet.